Okay, day 7 is about central angles and inscribed angles. And we've talked about central angles yesterday, so this example 1 should be a little bit of a review, because we know that if this arc right here has a measure of 101 degrees, that means this angle here is 101 degrees. So what we'll do real quick is we'll just go around and fill these in. It says HF is a diameter, so that means this arc right here needs to be 180 degrees. 180 minus 101 gives us 79 degrees. And then we know the whole circle has to be 360 degrees. So then I will do 360 and I will subtract those three numbers, 79, 101, and 125, and we're left with 55. So now I can go and answer the questions to the left. So the measure of FEJ, that angle is the same as this arc, so this will be 125 degrees. The measure of angle JEH, is going to be the same as this, which is 55 degrees. And the measure of arc JFG, is going to be this whole arc, so it's going to be 125 plus 79, or 204 degrees. The measure of angle GEF, is going to be the same as this arc measure, so 79 degrees. The measure of arc JH, well, that's going to be 55. We already have that labeled. And then finally the measure of arc GHJ, will be 101 plus 55, so 156 degrees. So hopefully this was a pretty simple review for you guys to go through. So the new stuff that we're going to talk about, the first one is called an inscribed angle. So look, the inscribed angle is different than the central angle. The central angle, your vertex is on the center. This inscribed angle, you see the vertex of the angle is on the circle. So in an inscribed angle, all 3 points are on the circle. See, A is on the circle, point D is on the circle, and B is on the circle. A central angle has the vertex on the center of the circle. And the relationship between the two is by 1/2. So if we took the measure of angle ACB, that is going to be 2 times the measure of angle ADB. So the central angle is bigger than the inscribed angle when you have the 2 same endpoints. So in other words, that this arc is 2 times the measure of this angle. So over here, the measure of angle ADB is 1/2 the measure of arc AB. I'll use the same color. So this purple arc is related to this central angle because the the inscribed angle. This inscribed angle is 1/2 of this arc. So let's see some examples of this. So we are asked here to find the measure of angle GHJ. So we're asked to find this angle measure. And we are given this part right here. The arc is 100 degrees, so that means the angle must be half of that, so 50 degrees. Right, then in example B, we're going in the other direction. We're trying to figure out the arc, but we're given the angle. So then the arc has to be 40 times 2, so 80 degrees. It can be confusing or tricky to know, well, do I divide by 2 or multiply by 2? The way I think about it is that, this arc is bigger than this arc here, this angle. If I were to draw this in, this angle is smaller than this arc. So if we're trying to find the bigger part, we multiply. If we're trying to find the smaller part, like we are over here, you would divide. And that seems to have helped students in the past. Alright, let's look at example 3. We have a lot going on here. They tell us that RS is a diameter. That's important because then we know that this whole arc is 180 degrees and this whole arc is 180 degrees, and that will help us. So let's look at what we're asked to find first. The measure of angle S. So the measure of angle S is right here, and if we draw in the angle, see, these are the endpoints, and we are told that that arc is 60 degrees, and since we're trying to find the angle, the smaller part, we're going to divide 60 by 2 and get 30 degrees. Now, letter B, the measure of arc, RQ. Well, RQ is the smaller part up here. Well, if we know the whole thing is 180, we can figure out what this part is because we have this inscribed angle. The inscribed angle is 37, which makes the arc 37 times 2, and that is 74 degrees. So then we can do 180 minus 74, and that would give us 106. So this part right here is 106. So 106 degrees. The measure of arc TS. Okay, well, again, this whole blue one down here is 180. We know that this part right here is 60, so that means the part left over must be 120 degrees. So 120 degrees. And then the measure of arc QS, oh, we already have that. That's 74 degrees. The measure of arc SQR, so SQR, well, that's half the circle, which is 180 degrees. And then finally, the measure of arc TSQ, TSQ. So it's going to be, we have 120 right here, plus 74. So 120 plus 74 is 194 degrees. So you need to really look at these problems bit by bit, and they build off of each other. So make sure you're careful in your calculations when it comes to these problems. Alright, let's go to the next page. One of the things that's easy to miss is that when two inscribed angles have the same arc. So if we look at this picture, okay, here's your arc AB, and you have angle ADB, this inscribed angle, and then angle ACB, this one right here, has the inscribed angle. Since they both have the same arc, that means both of these angles, these two angles, are congruent. So over here, that's just what this is saying. Angle ACB. Those two angles are congruent. And it's easy to miss that. Okay, we're going to use that information to solve example number 4. Now, we're going to name two pairs of congruent angles in the figure. So we have this arc right here, okay, and we have this angle, and we have this angle that make the same arc of PQ. So we have angle PSQ and angle PRQ. Those two angles form the same arc, so they're congruent. Then another set is we have arc SR down here, and we have angle SQR and angle RPS. So angle RPS and angle, so we did RPS and RQS. Those are congruent angles because they have the same arc. Now let's look at some of these other problems here. We want to find the measure of angle SPR. SPR. Okay, well, the arc measure is 81 degrees, and we're trying to go backwards here, so it will be half of 81 degrees, or 40.5 degrees. Okay, now the measure of arc PQ. Well, to find the measure of arc PQ, we know that these lines are diameters and they intersect, so we have vertical angles. Angle STR is a central angle, so this is 81 degrees, which also makes this 81 degrees. Angle PTQ. Well, the central angle and the arc measure are the same. So if this vertical angle right here was 81 degrees, that means the measure of that arc PQ is also 81 degrees. Right, letter D, the measure of angle PTQ. Oh, PTQ, we already have that. It's 81 degrees. E, the measure of arc PS. Okay, arc PS is right here. Well, we have a semicircle right here, which is 180 degrees. This part is 81, which means the remaining part must be 180 minus 81, or 99 degrees. Alright, then F, the measure of PTS. Oops, I didn't get 90, or is it 99 degrees? Okay, so then F, the measure of PTS. Well, if we know that this arc measure is 99 degrees, then the measure of this central angle is also 99 degrees. And then finally, the measure of arc SPQ. SPQ, well, that's another semicircle because, if we get rid of all this stuff real quick, SPQ, that's a diameter right here, so that's 180 degrees. Okay, so the main thing that you have to differentiate between is the central angle and the inscribed angle. The central angle and the arc angle are equal. That is why that arc PS was 99 degrees. That made angle PTS also 99 degrees because that is a central angle. Now the inscribed angle is half of that measure. That is why angle SPR right up here is half of this measure, 81. That's how we got 40.5. Alright, the last thing we're going to talk about are circumscribed angles. You know, an inscribed angle, the angle was inside the circle. A circumscribed angle, the angle is outside. So it's an angle that's outside the circle formed by two tangent lines. So we have TP as a tangent line and TR as a tangent line. So the theorem says that if I have two tangents that intersect outside the circle, okay, then the measures of the arcs formed is the difference between the measures of the intercepted arc. So this angle right here is 1/2 the difference of these two arcs. So you'd have to subtract those and then multiply by 2 or multiply by 1/2 or divide by 2. So let's look at some examples. We don't have very many of these. So a whole circle is 360 degrees. So if this arc right here is 138, that means the other arc has got to be 360 minus 138, which is 222. So this arc is 222. So then the measure of angle T is going to be 1/2 times 222 minus 138. And then we can type that into our calculator. And you can type that all in at once if you want to, instead of bit by bit. It doesn't really matter, but just make sure that you're setting it up correctly. So I get 42 when I type that into the calculator. Okay. If you type it in exactly like this, you will get 42 degrees. Right now, letter B. Okay, this part is 232 degrees. This part's got to be 360 minus 232. So I get 128 degrees. So then the angle measure right here, that is going to be 1/2 times 232 minus 128. And again, if you type it like that, you'll be fine. You could also replace 1/2 with 0.5, and you could you'd get the same answer as well. So I do that, and I get 52 degrees. Alright, so I know there were 3 different things that you learned here, so I know that's a lot. Hopefully you found this last one not as intimidating, that it's okay, that that you're comfortable with this. You know, this stuff up here I know can be a little bit more confusing just because there's so much of it. So try your best, and let me know if you have questions.